We are excited and we appreciate your time with us today for our webinar, Boost Your AI Development with ClearML and NVIDIA TAO, with our guest speaker from NeuralGuard. I'm Tina Naro, Senior Director of Product Marketing and Growth, and we'll be hearing from some awesome speakers. But before we get started, let's just go over a few housekeeping items. This session will be recorded and it will be available later. If you have any questions during the session, you can submit them on the chat window on your bottom right-hand corner. We have moderation on, so you won't see yours or you won't see other people's questions, but we will address them at the end of the presentation. And also, please be aware that this content is copyrighted material. It's meant for this session and individual use only. If you or your organization would like to use any of these materials, you can contact us at pr@clear.ml. So without further ado, let's introduce our speakers. Today we have Moses, Chintan, and Raviv. Moses, if you wouldn't mind saying a quick sentence about yourself.
Hi, I'm Moses. I'm the CEO and founder of ClearML. Pleasure to be here.
Chintan?
Yes, hello everyone. My name is Chintan Shah, and I'm the product manager at NVIDIA. I'm responsible for a lot of our Vision AI products, and good to be here.
Awesome. And Raviv?
So hello everyone, my name is Raviv Pavel. I'm CTO and co-founder of NeuralGuard. Happy to be here.
Excellent. I'm excited to have you here with us. So today our agenda is we will first have Chintan give an introduction to TAO, and then Moses will talk about a little bit about ClearML, and Raviv will wrap up with a customer story, followed by Q&A. So without further ado, I'll pass it to you, Chintan.
Oops. All right, thank you, Tina. Good evening, good morning to everyone. As mentioned, my name is Chintan, and I'm the product manager at NVIDIA. And today I'm going to give you a quick overview of NVIDIA TAO. TAO, which is our low-code AI toolkit. It's built on top of TensorFlow and PyTorch of the world, but we abstract away the deep learning complexity by making it easy to use. And the way we do it is we package everything in a easy-to-use Docker container, and we expose all the models with a config file and a Jupyter notebook. What we have here is you can have data, and data could be real or synthetic data, and this can plugged in to TAO to quickly fine-tune the model, optimize the model. You have a large selection of pre-trained models from CNN to transformer models, and I'll talk about all the different models that we have. And what TAO provides is the training, fine-tuning capability, along with model optimization, inference optimization, being able to trim down the size of the model. We have lots of optimization techniques like model pruning, where you reduce the size of the model, quantization, where you can reduce it to lower precision bit, floating point, FP16, or int8. And lastly, all of our models can be converted to TensorRT. So if you're deploying this on an NVIDIA GPU, all of our models can run on TensorRT. Finally, on the output side, our model export is through ONNX format, and this can be deployed on any platform, from GPU, CPU, microcontrollers to any other accelerator. TAO is open source. This is something that we recently announced a couple of months ago, and this allows much greater flexibility for anybody to use TAO, anybody to customize it, as well as build on top of TAO. So now, with that said, let me quickly talk about some of our features that we have. TAO, as I mentioned, we have a large selection of pre-trained model, but TAO is really packaged as a Docker container, and our developers can use the container as is, or you can also deploy it as a service and use it via our REST APIs. And the key capabilities that you can do, as I mentioned, training and optimization, and you can train the model from scratch, or you can fine-tune it, take one of our pre-trained model and fine-tune it on a subset of your data set, and then optimize it specifically for inference as well. We have features like AutoML, and what AutoML provides is an ability to train your model to sweep a set of hyperparameters on your model. You do smart hyperparameter optimization to give you the best model, the most accurate model for your given data set. We have other features like AI-assisted annotation, and what this provides you is an ability to take your data set, an unannotated data set, and convert it into generate a mask or segmentation mask. The input to the AI-assisted is an image with bounding box annotation, and output is a segmentation mask. And this uses our mask auto-labeler model, which is a class-agnostic model, so it works on most objects as long as you define it with the bounding boxes. And as I mentioned, this kind of builds on top of the deep learning frameworks like TensorFlow and PyTorch. And then on the output side, you can export it to Onyx, or you can export it to TensorRT. TAO can be run on practically any platform as long as it has an NVIDIA GPU. So this could be on a workstation, this could be a DGX workstation, a server, or anywhere in the cloud. So I talked about our pre-trained model, and we have like 100 plus pre-trained models from like the traditional CNNs, the ResNets, the YOLOs of the world, but more to the newer architectures like vision transformers. And we've seen vision transformers being kind of invented in 2020, and now it's most of the newer vision models are all transformer-based models. So we are double downing on transformers. This can give you much higher accuracy, much higher robustness than the traditional models. We have tons of vision transformers. We have transformers for classification, object detection, segmentation use cases. We're also creating some new models to plug it into other vision modalities. Foundational model is something that was started by in the LLM space, and now we're starting to see this large foundational model being used in the vision space, where the pre-trained weights are trained on a image plus text pair. And what this gives you is you can now train large model without having to create a lot of labeled data set. And that's always been a limiting factor with a lot of these models, is creating a labeled data set. But this foundational models, they're trained on few hundred million image text pair, unlabeled data, unsupervised learning, and this generalizes much better. And then you can quickly take this, plug it into your use case. You can do zero-shot detection classification, or you can fine-tune it with a subsample data. Other models we have are like Siamese model, where you're comparing where you're comparing two objects, and you're trying to detect the anomalies between the two objects with our visual change detection. And for this, you can we support segmentation, where the use case could be like an inspection use case, industrial inspection use case, where you really want to know where the exact defect is. And by comparing two objects, let's say a golden object and a test sample, you can estimate the exact location, exact spot for the defect. And this is brand new that we have added as a part of TAO 5.1, which was released last week. And other models, I mentioned about the mask auto-labeler model. This is a model for doing AI-assisted annotation. This is a class-agnostic model where the data is an image and a bounding box of the object that you're trying to segment, and the output is a segmentation mask. And all of our models are optimized to run across all of our GPUs. So all our models, even the largest vision transformer, works on our Jetson or inline, all the way to our larger A100 and H100 GPUs. So all in all, I mean, we have tons of models. So whatever your use case is, you can likely find one of the models that suits your need. So I mentioned about our AutoML capabilities, and we provide several algorithms for users to select in our AutoML, and we make it super easy to use. So if you just want to quickly get started, this is my data set, this is the model that I want to train, go figure out. You can do that. You can take one of our Jupyter notebooks, select your data set, and then quickly spin up a bunch of training runs. And all the beauty is this can automatically scale your jobs, because with AutoML you need to spawn off multiple jobs in parallel. So if you have multiple GPUs, if you're running in a multi GPU multi node cluster, it knows how to scale those jobs extremely efficiently. So you don't have to worry about it, because like with AutoML, right, you can spawn off like anywhere from like few jobs to like tens of jobs. Uh, but if you're somebody who wants more control and you want to know that, you know what, I want to change, I want to be able to sweep A, B, and C hyperparameters, you also get that granularity as well. So we provide the flexibility for our users to train or to configure any of the hyperparameters to be able to do with our AutoML. And the main thing is like the hyperparameters will have to change from dataset to dataset. So with this AutoML, you can have a baseline accuracy, which is like a default accuracy, and then turn on AutoML, and then you can see the accuracy jump up significantly. And this is supported on all of our models, including the new vision transformer models, the ones that are highlighted in green in this table. So our user developers can try AutoML on practically all TAO models. So other thing is we're pretty cloud agnostic. As I mentioned, you can run it on a workstation with a GPU, or you can run it with any cloud providers. And we're plugged in with various cloud services as well, from AWS, Google Cloud, and Azure. So you can use it at the compute level. So one option is you can deploy the infrastructure and use one of the TAO containers directly there, or you can spin off other additional services. Like for AWS, you can deploy the entire TAO service on the EKS, the Amazon's Kubernetes cluster. For Google Cloud, you can all use it with their Kubernetes cluster GKE, or we've also integrated with their other machine learning frameworks like AI. For Azure, we work across Azure AKS, which is their Kubernetes service, and Azure. So moving on, one of the key things that we have for TAO is and the idea is that you can take TAO, you can deploy it as a service in a Kubernetes cluster, and connect to using HTTP request. And yeah, in this case, you can have this in a Kubernetes cluster and integrate your own workflow. So I can imagine you can build your own UI on top of TAO. So TAO could be running in a remote cloud, in a remote workstation, and use your UI or a remote application. You can also use TAO and log into ClearML, and that's really one of the things that we have is be able to log all your training runs into ClearML. And I'll show you what are the things that you need to do and what are the logs that it provides. But the APIs can provide you a way for anybody to build additional services on top of TAO. So and allows you to automate your training process. So to kind of summarize, I talked about some of the key features that we have in TAO, from AI-assisted annotation, and this is specifically for segmentation use case, and where your input is the images and bounding boxes, and output is a segmentation mask. We are investing heavily in a lot of the state-of-the-art models, the vision transformers, and foundational models. We really feel that's the next wave of innovation in vision AI, and this large models, large even what we are working on next is like large multimodal model where we take vision plus speech and other modalities. The entire framework, what I showed today, is completely available as an open source. So you can take it, build on top of it. You can deploy it on any platform, and also you'll get all the great features like AutoML, where you can quickly try out a bunch of runs and see which model works best for your use cases. And then lastly, the REST APIs, and also our turnkey optimization, inference optimization like pruning and quantization. So all in all, I mean, it provides a rich set of features. Our newest version that we announced was TAO 5.0. We announced it a couple of months ago in July, and then we've added another revision. We just released a dot version with some new models, and then we have another dot version that's coming out in November. So a lot of rich features, a lot of models. Anything, I mean, depending on what your use case is, we support large range of vision modalities for many use cases. So before I kind of hand off the slide to Moses, I do want to talk about the integration of TAO with ClearML. So using ClearML with TAO is practically turnkey. We have done the integration ourselves, and the way we kind of describe it is like three simple steps. First, install the ClearML library on your workstation that you're running the TAO service, and then authenticate your account. So the way we make this available is set some environment variable, and these are what gets picked up by the TAO Docker container. And then lastly, TAO is fully configurable via a config file. So in one of the TAO config files, set your logs, set the visualizer parameters to true, and then set your ClearML config. And then once you do that, it'll automatically start logging into a ClearML dashboard. This is all covered in our documentation. And with that said, I'll pass this over to Moses. Thank you.
Thank you, Chintan. And with that, I'll give a brief introduction on ClearML, and then we'll connect it right back into TAO. So I'm Moses. I'm the CEO and founder of ClearML. Open sourced and founded in 2019. We have thousands of users throughout the world. We are 100% open source, both backend, front end, and client end. Of course, we have very large organizations using us through production, from small startups to the largest enterprises you can imagine in production, deploying in scale. Today, we'll concentrate on specific use cases, which TAO is a terrific example of, and later we will expand with how customers actually combine the two, and the benefit of the acceleration in terms of R&D and into production, in combining an out-of-the-box solution with the ability to customize. Just as a background on what ClearML covers, so ClearML is really an end-to-end platform that is custom tailored towards deep learning and generative AI, of course, covering also traditional machine learning, but a lot of the benefits that we're seeing from customers are coming from deep learning, where the remote GPUs and GPU machines make things a bit more complicated. So we have the data ops as part of the system. So imagine your data catalog and the hyper data sets, which we'll demonstrate a bit today. The experiment management, the training and the remote training, the reporting capabilities, basically producing dashboards, reporting, etc., into to management, making sure that everyone understands where projects are at. And of course, shifting towards production, the model source and the model repository, pipelines, and automation, including integration into any CI/CD systems like GitHub, Bitbucket, GitLab, etc. And of course, deployment of models, both in embedded scenarios and on the cloud. TAO is a terrific example of an end-to-end optimized system. If you're using TAO, since it's optimized with TensorRT, then deployment with ClearML serving actually utilizes NVIDIA Triton, which means you're getting the best performance in terms of hardware and software combination. Everything, of course, sitting on top of our orchestration solution that fully abstracts compute. So you can do it on bare metal, Kubernetes, cloud, whatever makes sense. The idea behind the ClearML and the TAO, NVIDIA TAO integration is making things as seamless as possible. So you guys don't have to worry about integrating the different frameworks into your code. And basically the idea is ClearML should be transparent. Just add 2 lines of code and we do all the heavy lifting. We are fully integrated with all the different deep learning frameworks, of course, with the serving as well. And we're fully cloud agnostic and hardware agnostic, which means you can run it on any cloud provider, any on-prem, bare metal, or Kubernetes, even integrating with Slurm HPC clusters. Diving into the actual use case. So today, jumped a bit here. And the idea of using ClearML, and this is what we'll demonstrate here today, is basically short-circuiting the data science aspect of things, the research aspects with the product, with the specific use cases and applications. That means that every step along the way, one of the personas here will have to contribute their side of things into the process. But once that's done, we can reproduce and repeat that process with a single click, really accelerating the process of R&D to production and getting feedback from the field itself, which actually increases the accuracy of our models and the performance of the application, etc. And that's at the end of the at the end of things, the target of everything that we're discussing here today. So specifically, how exactly the ClearML and the NVIDIA TAO work together. So let's think about it as a process. The first step is actually running the NVIDIA TAO on your machine, whether this is a local one or a remote one. The way that works is you can just jump right into the NVIDIA TAO Jupyter Notebooks examples and run a few of those examples. At the end of the day, what they do is they configure the NVIDIA TAO command line interface that spins containers that actually run the training or inference code itself. Everything else is a configuration one way or another of data either mounted into the containers and parameters that are needed. The idea is the algorithms themselves or the models themselves are already baked into NVIDIA TAO, meaning you don't have to worry about the complexity of running your latest and greatest computer vision transformers, but concentrate on the data and the type of model that you're trying to train or to test out of the box. And the NVIDIA TAO does everything for you in terms of packaging really the state-of-the-art capabilities. What ClearML does is creates visibility into this process. So while you're running it inside your Jupyter Notebook connected to NVIDIA TAO, what ClearML does in the background, it logs everything. That means you have scalars and accuracy numbers and debug images on everything that's going on inside the training or inference process. And with that happening in the background, everything is logged to ClearML. So everything that you're doing, you can later compare and trace back into the specific data sets and parameters, etc. But the main goal of this process is to make sure that once everything is executed on your own machine, someone else can take that process, and we'll demonstrate that in a couple of slides, can take that process, repeat it with maybe a different data or different parameters on remote machines directly from the ClearML UI, automating this process. So you can start the process of training, making sure that you have a small MVP that is working, and then shift the weight to the application users, actually fine-tuning the entire process on specific data sets, specific scenarios, everything that makes sense in terms of the actual use case that is a bit outside of the scope of the engineering efforts or the data science efforts. And that's exactly what we see in the second half of this diagram. This is user B actually launching jobs directly from the ClearML UI using the ClearML agents running either with the autoscaler, so scaling automatically spinning instances in your cloud account, or connected to your Kubernetes cluster, or even running bare metal on bare metal machines with a GPU backing them. And the ClearML agent actually recreates the same environment that the original NVIDIA TAO was running in, alongside different data sources with different parameters to repeat the process and continue the training and testing directly from the UI of ClearML. That really accelerates the process. So let's see how that actually translates into concrete steps. So step number one is, of course, finding the Jupyter Notebook or running the original TAO, integrating that with ClearML. As Chintan said before, this is basically setting up some environment variables and making sure that the configuration points to all the different types of visualization that you want to add. Everything else is fully integrated out of the box. Second step is, of course, reviewing everything inside ClearML. So all your logs, scalars, 3D graphs of derivatives, weights, etc., are automatically logged into the system, so you can have visibility into the process itself. Of course, also you have logging of the different samples being used or being verified. This gives you some intuition on the performance of the model itself. With that in mind, after you have that, you can start to automate the process. And what we're seeing now is the process of actually repeating that same process, same training inference that we started with TAO directly from the ClearML UI. So on the left-hand side, we can see the dashboard, all the different machines connected to ClearML. So this might be the autoscalers, a Kubernetes cluster, bare metal machines connected. On the right-hand side, we can see how we can launch a pre-existing experiment, the one that we just created with the NVIDIA TAO, creating a new one, cloning it, changing some parameters, and sending it for execution on the cluster that we have pre-set up or pre-configured. Again, this is dynamics clusters. That means that we'll spin automatically instances based on usage and quotas that is pre-configured, running those trainings or inference in the backend. Specifically, we also talked about the different aspects of data, and this is important. In the case of computer vision, and this is where NVIDIA TAO shines, is the ability to also connect data from a different perspective, meaning slice and dice the data that comes into the training or inference based on metadata. This is where ClearML hyperdata sets comes into play, allowing you to create live data sets based on queries on metadata. Imagine type of objects, metadata on the frames themselves, or video files, so rainy, night, day, etc. Combining those queries in real time, so there's no need to pre-create data sets, storing those data views and passing them as a subset of images or samples to either train or test your models. And of course, we allow you to also dive into the different details of the metadata itself, visualize the boxes, masks, etc., just to create better visibility into the data that is being used while training or testing the models themselves. Of course, once you have the model itself trained, you can deploy it with the ClearML serving, and maybe we'll have a webinar just on that, utilizing NVIDIA Triton to fully optimize the serving of those models that you train with NVIDIA TAO. This is really an end-to-end optimized solution. And with that in mind, kind of segueing into the a real-life production example, I'll give the stage to Raviv here to tell us a bit about how they utilize these processes.
Thanks, Moses. My name is Raviv Pavel. I'm CTO and co-founder of NewGuard. I've been doing software engineering for the past 30 years, which makes me feel very old all of a sudden. And I was focusing on AI for computer vision for the past 6 years. In this short presentation, I'll briefly describe what we're doing at Neural and then I'll share some insights from our experience in developing AI-based products, which I hope you'll find helpful. And specifically on the importance of using frameworks such as TAO and ClearML for speeding the development process. Okay, so NeuralGuard. We're doing AI for X-ray screening. On your regular X-ray checkpoint or checkpoint with X-ray, there is a long line of passengers waiting for someone to look at the X-ray imagery and identify whether there are prohibited items in your bag. Unfortunately, human operators have low detection rate or not as high as we would want to, and they're pretty slow. That's why the line is long. They are expensive, so the operation expense is very high, and there is not much interconnectivity between a human operator and some other systems. You can connect that person to other systems, and you cannot measure their performance. What we do is we provide a device which connects to the X-ray machine, helping the human operator detect prohibited items in the X-ray image. We have 90% detection rate with very low false alarm rate, which means that your bag is not being opened unnecessarily, that the line is going 3 times faster. Obviously, the cost of operation is lower. You need less people telling you to take your laptop out and all that, ritual. The reason you're taking the laptop out is because it obscures the image. It's very hard to see. And without solution, you need less people. Everyone's happy. The line is moving faster. Just so we know what the data set looks like, this is an X-ray image. This is your tray, the tray that you pass through the X-ray X-ray scanner, sorry. We can see a cell phone here, actually a couple of cell phones, some aerosols, maybe a hairdryer. So this is the image. This is the data set, obviously very different from COCO or ImageNet of cats and dogs and cows, etc. So what are the challenges that we're facing as a company developing this product? So we have multiple product lines, which means we train and deploy multiple models in production. It's not an experiment. It's a product that airports and other facilities rely on for security. The models are constantly evolving, right? People or authorities want to detect new items all the time, so the product is evolving. It's not a fixed model that you trained and you're done. The data set is ever changing. We have a data production facility where we have X-ray machines, and we create data daily. And we also have data from the field, which we gather from in deployments. So it's not a fixed data set. It's not a library or a folder with images. It's more like the hyper data sets that Moses mentioned, with many, the metadata about the image is very rich. We store all the aspects of the image, obviously when it was taken, but how complicated the background is, where is it coming from, the resolution, very long list. And we have lots of operational fields on the data. I know it sounds obscure, but it will be clear in a moment. Another challenge is that we have various deployment options. At the end of the day, the model can be either deployed on an edge device. I'll go back for a second. Here you can see that, that box here. That's a standalone edge device. It's not connected to the network because it's not allowed. So we need a way to deploy the models here, but also we deploy models to the cloud for third parties, and then we expose them as REST API. So there's a challenge around doing that. And at the end of the day, we're a startup. We have limited resources. We have to do all that and do it very fast and with resources and their cost in mind. So how do we do that? I'll describe, the process obviously is very, very complicated, and there are many aspects to it, but I'll try to focus on, the high level stuff and connected to our topic here. I always say to my peers that model architecture is not your biggest problem when you develop an AI-based product. Sure, it's important. You need to pick a good model architecture, whether that be faster than LCNN, in YOLO, etc. They all have their pros and cons, but that's one problem. The workflow, the data-driven workflow of creating a product from data. You start with your data, and you end with a model deployed on the edge device. There are many things, many issues that you have to address if you want to do it efficient, with fast time to market, and have traceability and know what you're doing and be able to reproduce things. This is not an experiment in academia. This is the product. So we all know that, on very high level, you have that process of workflow of training, evaluating, deployment. Then you need to have, or sometimes you have reinforcement learning with human feedback, meaning you take data that you saw on the field via the edge device, right? You deploy the product, and you have new insights on the data. You have new data. You want to feed it back to the system. You want this process to be automated, right? If everything is done manually, it wouldn't scale. Again, the difference between a small pet project and a product. You want to have visibility and traceability everywhere, because as a developer, you want to see how your models are doing, right? How well they're doing, how much data you have, what kind of data you have. You need traceability and visibility in all levels, in the level of data, right? So you need data set management. Like Moses described previously, we're no longer in the era of having files in folders. We need data set management, which allows you to provide metadata with your images, in our case, images, right? Because later on, when training, you want to train on specific subsets of the data set, right? If right now you have data, let's say in our case, coming from different X-ray vendors, X-ray machine vendors, and we have one model per vendor, you want to slice and dice your data set based on X-ray models, right? So the ability to query your data set, your hyper data set, in real time, and train your model not on your entire data set, but on a subset of it. And also to be able to give different weights to different portions of your data. For example, we all know that class imbalance can cause biasing, could cause bias, sorry. And we want to avoid that. We can control that by giving different weights to different classes. Or if you know that you have a specific class which is more difficult for the model, you want to give higher weight for that class in your data. When the model is seeing the data, you don't get equal balance. So that was about data set. When training, you want to have visibility into your training, what I described before, the ability to see dashboards and reports with all the metrics of your training tasks, to see what's wrong right now, etc. And at the end of the day, your model, your output is a model, and you need some model repository. Sure, you can just, again, use files and folders, but that doesn't scale, and it's very hard to track your progress when doing that. So there's a necessity for a model repository or model management. ClearML provides us these three these aspects, or this stack of managing datasets, experiments, models, and obviously when training, we use NVIDIA software and hardware. When deploying on the edge device, using NVIDIA software and hardware, and by that, and products such as TAO allows you to focus on the how should I put it? Maybe less exciting things like the data-driven pipeline, the data set, the repository, and take a proven solution or pre-built model, which in many cases you don't need to invent the model or code the model yourself. If you have a pre-built one that was already tested, and you just fine-tune it to your needs. I hope I have time to describe a use case for all this, data-driven workflow. Tina, do we have time? Okay, thanks. So to make it a bit more practical, and I know it might be a lot, but we're trying to do it very quick. I'll describe the process. I hope some of you know the concept of hard example mining. Right. The problem is that we have a very, very large training data set, over 10 million images. Now, not all images are equal to the eyes of the model. Okay. We need to draw the model's attention to hard examples, to cases where it fails. Obviously, we're talking about the training data set, not the test data set. And we don't want it iterating for vain or for nothing on images that it already detects well, because we don't want to waste GPU time on these easy ones. So the solution is to run model evaluation, find labels with low performance, okay, labels where the model is either not detecting or providing false positives. And then we need to mark them as being hard for this model. And I emphasize for this model because we have like maybe 10 models now training in the background. And I want to say that this specific model is having trouble with these images, okay? And by flagging them as hard, and because in the hyper dataset, I can give weights, different weights to different queries of the dataset, I can basically allow the model to see more of these hard examples. And obviously, after a while, the model is being trained on these, or it sees more, not just these hard examples, but it sees more of these hard examples. it should get better on them. And maybe now that the attention is drawn to these, we have an issue with others. That's a different issue. That's why we need to repeat and reiterate that until we reach the performance of the model. By performance, I mean that we have low false positives and low false negatives, obviously. Now, doing that without, I'll go back to the slide, doing that process, which I hope was not too fast, doing that process without the ability to automate everything, right? We need to run that hard mining process repeatedly, and we need to trigger that every time there is a snapshot. That's why we need automation. Without the ability to flag images with metadata, that wouldn't be possible. And also, as I mentioned, without the ability to specify weights for different subsets of the data, that also wouldn't be possible. So having this stack, all the facilities that ClearML provides us with, allows us to do that efficiently, to do the hard mining efficiently and automatically. And I must say that that's one of the examples of hard mining. That example of hard mining, that's something that we came across only when our product was so mature that you get into those. I mean, you're trying to increase, let's say, your accuracy from 85 to 87 or 90, and sometimes these are the that increase in performance takes the most effort, right? It's very hard. It's very easy to get to 70% accuracy or 80%, but getting those extra 10 requires a lot of work. And hard example mining help us do that, and without tools such as ClearML, and also if we had to focus on building and debugging models from scratch and not using pre-built models, that would also be almost impossible. So I hope with that, I hope it was helpful. And thank you very much.
Thank you. Thank you, Raviv. With that, we will move into Q&A. So please feel free to submit your questions for Moses, Chintan, and Raviv. We have a few minutes left, and we've already got some questions in, so let's get started. One question for Chintan was, is it possible to fine-tune clip models with the TAO toolkit?
Yeah, it is actually. So with our recent release, the TAO 5.1, we do have a fine-tuning capability on the foundational models. So clip is something that we do support. So yeah, do take a look at it, and you can just import the public clip model and then fine-tune the very last layer.
Thank you. Second question, this is for both Chintan and Moses. What is the licensing model for TAO in ClearML?
I can start on the TAO side. So on the TAO side, we have multiple different licenses. One, the entire tool is available as open source, so you can use it under an open source license. But obviously, you'll have to build everything. But we do have our EULA, then user license agreement. That if you download our entire package on NGC, we have that. And also, if you're planning to deploy this in production and you need reliability and uptime and support, we do have our enterprise version, which comes with enterprise license and enterprise support, and that you will get a lot more support. So those are the different licensing versions that we have.
And with regards to ClearML, so ClearML is open source. You can start with the open source free license. It's Apache 2 and SSPL for the backend. Spin your own server and connect it to your NVIDIA TAO execution. You can also use the SAS versioning, so go to app.clear.ml and start using that. And of course, we have the various enterprise licenses where we cover development and production and deployments of ClearML as well as ClearML servers in production.
Wonderful. The next question is also for both of you. Where can code examples be found for ClearML/TAO?
Yeah, from TAO, these are found in our Jupyter notebooks as well as in the documentation. So all the code or snippet that was shared was directly from our documentation, but that can be found also in our Jupyter notebooks as well.
Yeah, that's and I think that there is a reference from the ClearML documentation to the same website, so it's essentially the same instructions in both sites.
Great. And I think the next question, I'm not sure who it's for. How easy or complex is it to create and set up a mask auto labeler for never seen before items, which are not in any data sets?
So I'll take this one. With our mask auto labeler, it works reasonably well. We have a demo on TAO product page that shows how we use this mask auto labeler to label like random objects like oranges and people and things like that. So it works reasonably well. The only thing is the input you need the bounding box. So kind of you need to provide the information of which object do you want to segment, and then the mask auto labeler works reasonably well. If you find that, you know what, this still doesn't work very well for my objects, which are completely obscure, completely different than what any other previous data set has seen, then we do have an option where you can fine tune it. So all the things that we talked about, you can also fine tune this mask auto labeler with your own data set. And I believe it's a semi supervised learning, so you actually don't need the full label data of masks. You can kind of retrain it, fine tune it, and so hopefully your mask auto labeler model works better on your type of data set.
Awesome. And then we will just take one last question since we are running very short on time. Do we have any examples of a continuous learning process like the ClearML blog?
You mean in the ClearML blog or outside of the ClearML blog? I'm not sure I followed.
Let's talk about outside the ClearML blog.
We should probably add one. This is not very straightforward to set up. So continuously trained example, meaning this. So I'm sure, just so I'm clear on terminology, means running a model, collecting outputs from that model, pushing that into a data set, retraining the data set in the background, either continuously or once every X amount of hours, for example, and then redeploying the new model. Setting it up as a 1, 2, 3 example is probably a bit complicated. That said, maybe that's a terrific idea on the next webinar on how to do that with a very hands-on example of a use case. That's from our experience and our customers. It shows great potential, and it really works out of the box. As long as the initial model is trained to a point where it actually can achieve the challenge, and then it just refines itself.
Thank you. We are running very short on time. So anyone, all the other questions in the queue, we will respond to them individually so that you get your question answered. I just wanted to close up with resources. So we have a ClearML and TAO tutorial, also some NVIDIA toolkit documentation. NVIDIA also has a number of resources with regards to TAO, which I will be happy to drop into the YouTube notes in the description when this presentation goes live. And I just wanted to say thank you. Thank you to our speakers. Thank you to our attendees. We appreciate your time, and I hope you have a wonderful day. Thanks,
Thank you.
Moses, Chetan, Raviv, and everyone.
Thank you, everyone.
Thank you.
Thank you,
Have a
everyone.
good one.